All right, lesson 25, solving problems in two ways. I sometimes find that it's confusing to teach students two different ways to do the same thing, but I hope that you guys find some value in me showing you two different ways to do certain types of problems. First of all, let's work through this one. Solve the following problem first using a tape diagram and then using an equation. So in a school choir, half of the members were girls, assuming the other half were boys. At the end of the year, 3 boys left the choir, and the ratio of boys to girls became 3 to 4. How many boys remained in the choir? So I'm going to do a tape diagram. So initially, I've got the same number of boys as girls. Cool? And then at the end of the year, 3 of the boys leave. So at the end of the year, we've got, fewer boys, and the ratio is 3 to 4. So what we can do is say each square is 3. So I have 9 boys and 12 girls left in the choir. Okay, now let's try it again using an equation. So initially, I have the number of boys is B, and then the number of girls I can also say is B. And then at the end of the year, for the boys, I have B minus 3, and for the girls, I did it again. I've been putting T on that, GIRLS. So for the boys, and the boys I have B minus 3, and for girls I still have B. And then our ratio of boys to girls is 3 boys to 4 girls. All right, so let's set up our ratio and see if we can solve. I usually keep my ratios in fractions, 3 boys over 4 girls, so B minus 3 over B. I always cross multiply when I have fractions. So 4 times the quantity B minus 3 equals 3 times B. Distribute. Subtract 3B from both sides. Gives me B minus 12 equals 0. Add 12 to both sides. I get B equals 12. Well, if we look at the end of the year, the number of girls equals B, and the number of boys is B minus 3, or 9. There we go. We just solved an equation in 2 ways. Which problem solution, the one using the tape diagram or the one using the equation, was easier to set up and solve? Well, that's really a personal answer. I like equations. I can usually muscle through an equation and come up with some variables and some things to solve for. Drawing pictures is a great way to sort of visualize what's going on. This was 50-50, where for the equation we both had the boys and the girls equaling the same variable, which bothered me a little bit. But this was very visual, that saw that they were equal, and then when 3 left, I sort of knew how to separate the rest of my drawing, which was nice. But it's a very personal answer, whichever you like. Like I said, getting the answer isn't always the most important part of the problem. The process is really important, and how to get there. All right, this is going to be quite a journey working through this problem. So I'm going to ask you to stick with me and try to learn some new ways to think about things. This is really a mathematical modeling exercise, and it's pretty involved, sort of abstract, but quite fun to work through. So stick with me and take some notes. All right, read the following problem. All of the printing presses at a print shop were scheduled to make copies of a novel and a cookbook. They were to print the same number of copies of each book, but the novel had twice as many pages as the cookbook. All of the printing presses worked for the first day on the larger book, the novels. Then, on day 2, the presses were split into 2 equally sized groups. The first group continued printing copies of the novel and finished printing all the copies by the evening of the second day. The second group worked on the cookbook but did not finish by evening. One printing press, working for 2 additional full days, finished printing the remaining copies of the cookbook. If all printing presses printed pages for both the novel and the cookbook at the same constant rate, how many printing presses are there at the print shop? All right, so let's take some notes from this. First of all, what is the story about? Okay, the story is about printing novels and cookbooks. That's what the story is about. Will more novels be printed than cookbooks or fewer? We are printing the same number of novels and cookbooks. How many pages does the novel have compared to the cookbook? The novel has twice as many pages as the cookbook, which means the novel takes twice as long to print. Oops. As the cookbook. Is it important to know how many pages each book has or how many of each book will need to be printed? I don't think so, because we just know that it's equal amounts no matter what. We're printing the same number of books. We're printing the novel has twice as many pages, etc., etc. All right, let's ask a few more questions. We haven't really talked about the printing presses, have we? On the first day, how many printing presses were used to print the novel? How many? We actually don't know how many. So all of them printed the novel. On day 2, how many of the printing presses, how many of the printing presses are used to print the novel on the second day? So we had half of the presses printed the novel, and half of the presses printed the cookbook. On the third and fourth days, how many printing presses are used to print the cookbooks? So on the third day and the fourth day, we had 1 press on the cookbook and 1 press on the cookbook, which is sort of silly, isn't it? If we would have fired up 2 printing presses, we would have fired up 2 printing presses, we would have been done in 1 day. It is sort of silly. Not quite sure why they did that. So 2 printing presses could have finished the cookbooks on the third day. What are we trying to find in this problem? Our goal is to find the number of printing presses at the print shop. We have a lot to work through. Anybody else confused? Not sure how to solve this problem? But don't worry, we will get there. First, let's solve the problem. Nope, we skipped a page. We are going to solve this problem. And so it says it on yours is part A. We're going to solve the problem working with rates to set up a tape diagram, because some of you might like that. Or an area model. So if I draw sort of an area model, and I say this left side looks to be about twice as big as the right side. So the left side is going to be my novel, and the right side is going to be my cookbook, right? So on the first day, all the printing presses were used on printing copies of the novel. And on the second day, half completed the novel while half completed the cookbook. So on day one, let's say that on day one, we've got all printers. Right? On day two, let's erase that. On day two, we did half novel and half cookbook. That makes sense. Those are all equal slices, right? And then we've got this last little slice of stuff, right? So on the first day, all the printing presses were used on printing the novel. On the second day, half completed the novel and half worked on the cookbook. We split this into thirds because if all the printing presses completed half of the novel on day one, then half of the printing presses would only complete a quarter of the job on day two. Therefore, only 3/4 of the novel be completed by the end of the day two. So why did we split it into three? So on the first day, we've got 2/3. And on the second day, these are equal pieces, right? So I had to split them in thirds to make it all make sense. If I would have done half the novel on day one, and then I would have only had a quarter of the novel on day two, and we wouldn't have finished. So in all essence, I needed my novel split into 3 parts, where on day one, 2 of the parts are completed, and on day two, 1 part is completed, and then the whole thing is completed. And then this piece equals the cookbook, because on day two, most of the cookbooks were done. They just needed a little bit printed off on those last 2 days, which is just silly, right? So let's split that up. So that last piece is really day 3, 1 printer, and day 4, 1 printer. Silly people. That's really neat. Our tape model sort of worked. It's fun. All right, let's see where we are now. So what we can really say here is that the novel job is the whole unit. The novel job is the whole unit. And each third is a third of the whole. So So the novel job is the whole unit, and each third unit has the fractional third of the whole. So the cookbook job is then really half of the whole. Oops. The cookbook job's half of the whole. The same third must have also been completed on the cookbook job on day 2, leaving half minus 1/3, which if you get out your handy dandy calculators is really a 1/6 left for day 3 and 4, right? So a 1/6 is left for days 3 and 4, and if I actually did a half of a 1/6, I would get a 12th each day. Okay, go ahead and push pause and you can copy that down. Move into the next slide. So, hold on, let me draw. So if we look at this, let's see if I can discern this for you. I just recopied the drawing up here. Day 1, we did a third of the novels. Day 2, we did a third of the novels and half of the cookbooks. Day 3, a 12th. Day 4, a 12th. If I can sort of show us what these two, copy them throughout the tape diagram, I can split each day into pieces and parts. And what I show here is in day 1, I actually have 1, 2, 3, 4, 5, 6, 7, 8 printers. And then in day 2, I have 1, 2, 3, 4, 5, 6, 7, 8 printers. And then on the last day, the last 2 days, that's not 2 printers. The last 2 days, I had 1 printer each. I can only reiterate that this type of problem is not my favorite. I really like algebra. That's why I teach it. So let's go ahead and do this one more time with algebra. And again, I'm telling you guys, just stick with me. Please work through this. Practice makes perfect when it comes to these modeling exercises. So let's work through this one more time. So we are looking for the number of printing presses. That's what our goal is, right? The number of copies of cookbooks printed by one printing press in one day. One printing press. This is how we separated our tape diagram, right? We found that the printing press, what they could do in one day, and sort of divided the rest of the tape diagram up to match that. Let's say copies. Let's go, oh, I don't know why I said R. The number of copies of novels printed by one printing press. So if they can print one cookbook, novels printed by one press in one day, if they can do one cookbook in a day, they're going to do half a novel in one day. That makes sense. And then the number of copies of cookbooks and the number of copies of novels should be the same. Copies. Cool? All right, let's write down some expressions. what we can do. I'm going to get a new page, so I hope you wrote this down. All right, novels. So the number of novels, the number of copies of novels printed in one day by the entire shop, I've got half R times the number of printers we have. So 1/2 the copies of one printer, because remember, this right here is how many novels one printer can print, and this is the amount of printers we have. So if we multiply those, we would get the total number of copies that we've made. And then, so that's the number of copies of novels printed in one day by the entire print shop. Now we have, so this is one day, one day, all novels. That's when the print shop did all the novels. Now let's do day 2, when half the shop was doing novels and half the shop was doing cookbooks. So really we're doing half of what they did the first day, which equals 1/4 Rx. And so here we have day 1, here we have day 2. Day 3 we were done. So the total number of novels equals 1/2 Rx plus 1/4 Rx, which equals 3/4. If you add that up, you get 3/4 Rx. That's the total number of novels. Now let's look at cookbooks. Day 1, they didn't print anything. Day 2, we did half Rx. So we did half of the cookbooks times the number of printers. And then, so that's day 2, number of cookbooks printed one day by half the entire print shop. The number of copies of cookbooks printed in 2 days by one printing press. So this was day 2, and this would be day 3 and 4. Cookbooks. We did R plus R, which is 2R. Yep. And then the total number of cookbooks is 1/2 Rx plus 2R. Those don't match up very well. They don't all add up together because there's no X term in days 3 and 4 because we only had one cookbook. X was 1. All right, since the number of cookbooks and novels is the same, we can equate the expression of the totals above to get. So the number of cookbooks and the number of novels, that means we can set those two equations together. 3/4 Rx equals 1/2 Rx plus 2R. Very, very cool. R can't be 0. We can divide both sides by R, and we can divide everything by R because we know R is not going to be 0, and it cancels all of them out, and we're left with 3/4 X equals 1/2 X. I don't know why I wrote R, plus 2. Let's subtract this 1/2 X from both sides. We get 1/4 X left over equals 2. If I multiply this by 4 and that by 4, I get X equals 8. That means we have 8 printing presses in the print shop. I'm so happy we got the same answer. That'd be very embarrassing if we didn't. All right, that was sort of stressful for some of you, that those abstract problems are pretty tough. I'll give you that. But with the right amount of practice, you can get them, and we can figure all this out together. So we will do our problem set tomorrow. You'll have a little quiz first thing in class, so be prepared, take some notes, and it'll be easy if you take some notes. Cool? Cool.